So of course we're starting with straight lines initially, and you've been using these recently in your science unit of work. So generally when we write a straight line, it's going to be in the form y equals mx plus c, where m is the value of the gradient, which tells us the slope of the line, and c is the y-intercept. So the two skills we're looking at today is going from the equation of a straight line to producing a sketch, and also from a sketch going to the equation of a line. So a very simple example initially, y equals 7x, take 4. We see that the gradient is 7 and the y-intercept is minus 4. So producing a sketch here, I show my y-intercept of minus 4. So remember the y-intercept is the line when x equals 0. And then I'm going to use my gradient to find another point on my straight line. So a gradient of 7 means that if I go across 1 from my straight line, I need to go up 7 to get back to the line. Okay, so this new point here will be when x equals 1. So I've gone 1 across. And then I need to go up 7 from minus 4. So minus 7 plus 4 gives me 3. Okay, so the second point on my straight line is the xy point 1, 3. However, whenever we do a sketch, we should label all the intercepts. So here we see on my graph there's an x-intercept. So I really should calculate what that intercept is. But how do we do that? So to find the x-intercept, what you should do is write down the x-intercept is when y equals 0. So this is true for all x-intercepts. So this is a really magic statement. It works for every single function. So if you're ever trying to find an x-intercept, this should be the first line that you're writing down. I can't stress enough how important this is, how magical it is. This is tooth fairy magic stuff, okay? It's right up there, apart from the tooth fairy that visited our son and came 3 days late. But moving on. So the x-intercept is when y equals 0. So the equation of our straight line that we just sketched becomes, so sub in y is 0. So I'm trying to find the solution of x that makes this equation true. So working backwards, add 4 to both sides, divide both sides by 7, and I find that my x-intercept is 4/7. That means that the x-intercept is the coordinate, the xy position, when x is 4 and 7, y is 0. If you want to find the y-intercept is when x equals 0. So we need to sub in x equals 0 into our equation and solve. Doesn't make much sense when we have y equals 7x take 4 because we can read the y-intercept off from this form. However, if the equation is written differently, perhaps like 3y plus 4x equals 6, well then we can't read the y-intercept off this straight line equation and we need to solve. How we'll do that is sub in the condition when x equals 0 and solve for y. So if you want to sketch any straight line given in any strange form, you can find the two intercepts by subbing in y equals 0 and solving, and then you can sub in x equals 0 and solve for the y-intercept, and then produce a quick sketch. Now we'll have a look at going the other way. So if we have the sketch of a straight line, how to find its equation. To do this, we're going to be using the gradient point formula, which is y take y1 equals m times, in brackets, x take x1. So in this formula, m is the gradient of our straight line, x and y are our variables, and x1, y1 represents a point that the straight line passes through. So really this is just a different way to describe a straight line. So if we have a look at an example, we see that this is written in the form above. So I see y take 6 equals 4 times, in brackets, x take 2. So from this way of writing a straight line, I can read off the gradient equals 4. I can also determine an xy point that our straight line passes through. So x1, so 2, 6 is a point that this line passes through. So let's have a look at example 1. So we have find the equation of the line with a gradient of -3 that passes through the point xy equals 2. So there's our x value, -5, there's our y value. So for use in our equation, I've labelled my x coordinate as x1 and my y coordinate as y1. So here is the gradient point formula. So I'm subbing in y1 is -5, the gradient was -3, and the x value, x1 is 2. So this does describe the line perfectly. However, generally we want to put it back into the form y equals mx plus c, so we need to do a little bit of arranging. Okay, so expand the brackets, we get -3x plus 6. Be careful of your signs here. Y subtract -5 is y plus 5, then subtracting 5 from both sides, and we get the equation y equals -3x plus 1. More generally, we want to find the equation of a line if we're given 2 points, or perhaps a sketch showing those points. Now the points may be the intercepts. Okay, so you have to realise that the y-intercept of 5 is the xy point 0, 5, and an x-intercept of -3 is the xy point -3, 0. Or it could just be 2 points on the line. So let's do an example where we just have 2 points that are not on an axis. So example 2, we want to find the equation of the line that passes through the points 3, 11 and 6, 7. Sometimes it is a good idea to do a very quick sketch of your points, because straight away I can see I should be getting a negative gradient because the line is decreasing. Here I've written out my 2 points and I've labelled them x1, y1, my first point, and x2, y2, my second point. Which one you label as x1, y1 and x2, y2 doesn't matter. You'll get the same answer. Generally though, it's better to label the one on the left as your x1, y1. Just makes the equations a little bit easier. Our first step in finding the equation of the line is to first find the gradient of our line. You should be familiar from last year how to find the gradient when we know 2 points. So the gradient m is equal to y2 take y1 divided by x2 take x1. So looking at our sketch, y2 take y1 represents the rise, while x2 take x1 represents the run. Okay, so the equation is the rise on run that you're used to. So here, when we're substituting in our values, there's lots of room for error, so you need to be quite particular. I'm subbing in with brackets because I know sometimes I might get a negative coordinate and I need to be careful with my expansion. Here I don't, but you'll have to do trickier ones than this example. So y2 take y1, y2 7 take y1 is 11, divided by x2 take x1. And that gives me a gradient of -2, and I can do a quick check. Yes, I was expecting a negative gradient because my line is decreasing. So our gradient point formula becomes y take y1 equals -2, the gradient we solve for, times in brackets x take x1. So remember, the x1, y1 represents a point that the line passes through. So we can use either. I'll choose 3, 11, the nicest looking point. So we're subbing in y1 is 11 and x1 is 3. And again, we just need to expand and collect and write the equation of the straight line in the form y equals mx plus c. Occasionally you might have to write down the equations of lines that are either vertical or horizontal, and these are special cases that you need to remember how to do. So if we see a vertical line will pass through the same x coordinate. So here we see the line passing through x is 4, y equals minus 6, x is 4, y is 0, and x is 4, y equals 12. So the equation of this line is x equals 4. It's the collection of points that have an x coordinate of 4. Horizontal lines, like this one, I see they all have the same y coordinate of 7. So this line is the collection of xy points where the y coordinate is 7. I remember these equations simply by finding the intercept, 4 in this case, and looking at the axis it's passing through x. So this is the special line x equals 4. For our other one, it's passing through 7 on the y-axis. The equation of this line is y equals 7. Now you need to have a go at a few of these skills, looking at the question sets that I've put on Sector. Please also remember that your online textbook is a good resource here for more examples and questions. And you do need to practice these because they can get tricky just with negative signs being thrown in, making sure you're not making silly errors. But please remember, you can do this and we're here to help you.